Alright, in this video, we want to talk about the concept of binomial expansion. So you use binomial expansion majorly when you have situations where the power of your expression is quite high. For instance, imagine you're told to solve for to expand this value. Obviously, this will be a lot of work if you have to do this without using binomial expansion. So the major reason why we use binomial expansion is for situations where we are having uh, very high power of an expression. Anyway, you can actually use it for smaller powers or for uh, a much bigger power. But the main reason why you would want to adopt binomial expansion is because of higher powers. So let's talk about the concept of binomial expansion very quickly. So let's say, for instance, you have a plus b raised to power n. A plus b raised to power n. So what is the concept of binomial expansion while you have a situation like this? Binomial expansion is given as the summation of n k. I'll be explaining all these terminologies very soon. And this will be a raised to power n minus k, and then b raised to power k. Now, the summation we have here, k here will range from 0 to n. So this is the general expression for a binomial expansion. And to understand everything we're dealing with here, number one, the n value here is actually the power of the expression. So n here signifies the power of the expression. In this case, now your n was 10. Now, the a value here obviously is the first term in the expression. So in this case, if we were solving this particular question, your a here will be 2. And your b is actually the second term of the expression. In this particular case, it would have been minus 3x if you were solving that particular expression. Now for your k is an incremental value that will range from 0 up until the n value. So, and don't forget, this is a summation. So what you'll be doing here is you'll be having to sum up the different terms. So for when k was 0, that will be your first term. So you fix k as 0 here, and that will be your first term. When you have k as 1, that will be your second term, k as 2, your third term, and so on, up until you get to your k being n. Now, for this last thing you have here, the n combination k. The n combination k, what you have here is actually combination. So nk is actually the same thing as n combination k. And the way you solve n combination k is n factorial over n minus k factorial k factorial. So there are three different ways you can solve for combinations. You can decide to make use of this particular method, or you can make use of your calculator, or lastly, you can make use of what we call the Pascal triangle. We're talking about the Pascal triangle in a bit. So those are the three different ways you can use to find your combination. So let's solve a very simple example very quickly, and let's see how to apply the knowledge of binomial expansion. So let's take a very simple example to start with. Let's say we have x plus y raised to the power of 2, and we're told to use binomial expansion for this. If you have a question like this, what you have to do is just apply the very same formula we have here. Of course, the first thing to do is to use your k being 0. That will always be your first term. So for your first term, your k will be 0. For your second term, and so on, you keep increasing the value of k. Your n here is 2. Your k here will start from 0 up till 2. So to solve this, we'll be having the first term will be 2 combination k, which will be 0. 2 combination k, which was 0. The first term. And then your a value here is x. That will be x. I always prefer to use the bracket because of complex situations. So that will be x raised to the power 2 minus 0 Then y, the second term here, raised to power 0. That was based on what you have here. So that was for the very first term. And for the second term, you will have plus 2 combination. The next one will be 2 combination 1, because your k will increase from 0 up to 1. Then you have the same thing. It's only your k value that will differ in this particular second term. The same values you have here will be the same value. Only your k value will be the changes. That will be x raised to power 2 minus 1, y raised to power 1. And then the last term will be, please pardon the use of the space, I will adjust on that very soon. So the last term will be 2 combination 2. Then you will have your x raised to the power of 2 minus 2, and then y raised to power 2. So this is how you express your expansion. Number one, don't forget the use of the summation is that all the terms are going to be added. That's what you have, plus and plus here. And then the n value here was 2. So you started from 2 combination. The very first term will be having a k value of 0. So you keep on increasing that k value up until you get to k being n. And then your a value here was x, and your y was your b value. And you follow the formula n minus k, which was 2 minus 0 in this case, and k was 0. Then you then go on to complete this. 2 combination 0, if you press that on the calculator, will give you 1. So solving this question here, so 2 combination 0 is 1. That will be x raised to power 2 minus 0, that's x raised to power 2. Y raised to power 0, y raised to power anything will be, y raised to power 0 will be 1, because anything raised to power 0 is 1. Plus 2 combination 1 will actually be 2. If you press that on the calculator, 2 combination 1 is 2. So you have 2. Then you have x raised to power 2 minus 1. That's x raised to power 1. So you just have your x value alone. Then you have y raised to power 1. So you have your y value alone. Plus, we have 2 combination 2. If you press that on the calculator, 2 combination 2 will give you 1. And x raised to power 2 minus 2, this is 2 minus 2, that's x raised to power 0. 2 minus 2 is 0. That means you'll be having x raised to power 0, that's 1. Then you have y raised to power 2. So you can see how by using a simple scenario, we are able to get our results very easily. So this is 1 times 1, that's 1. So we'll be having x squared plus, this will be 2xy, then plus y squared. That means we can conclude that x plus y raised to power 2, this is the solution. So this is quite very simple. We can have a much more complex and more larger sum to do. So in our next video, we'll be talking more on the theorem and solving a much more complex situation. So this is just a basic example on how to apply the binomial expansion. Once you follow this procedure, you cannot get a wrong answer. Thank you guys for watching. See you in the next video. Bye-bye.